Good morning, students. Today we are going to study operation on real numbers. See, real numbers satisfy the commutative, associative, and distributive laws. See, students, these are the laws for addition and multiplication. We have already studied these laws in our previous classes. Just have a look. So, here it is commutative law for addition, for multiplication. So these laws are very simple. Left hand side should be equal to right hand side. So it doesn't make any difference if we add first A or B. Okay. Now comes your associative law. This is for addition and this is for multiplication. Similarly, we know that this is our distributive law. So all these properties, commutative property, associative property, distributive property, we have already learned in our previous classes. So here we are just revising it again. So what is the first property of real number? That a real number satisfy commutative, associative and distributive laws. Next, if we add, subtract, multiply and divide except 0 to rational numbers, we get a rational number. See, it is very important, students. This statement is that if we add, subtract, multiply and divide in division, we have to accept 0. Means we do not want to include 0 in the division. So if we are taking two rational numbers and we are performing four mathematical operations, that are addition, subtraction, multiplication and division, so what is the result? We always get a rational number. But this statement is not true for irrational number. See, in case of rational number, we always get a rational number, but in case of irrational number, it is not true. Why not true? Let's have a look. See, in rational numbers, if we add, see here, all the four mathematical operations are there: addition, subtraction, multiplication, and division of two rational numbers. What is the result? Always a rational number in all the cases. And what in case of irrational number? See, when we again four mathematical operations are there and two irrational numbers are there, but the result is either rational or irrational in all the cases. What does it mean? That it is not necessary that the result is always rational or always irrational in case of irrational numbers. But in case of rational numbers, it is certain that the result is always rational. So let's have a look over the examples to better understand this property of irrational numbers. See, here it is the addition operation. See, this is the rational number and this is also a rational number, and what is the result? 2, which is a rational number. Here same addition is there. See, this is a rational number, this is a rational number, and the result is also an irrational number. So I have given two examples so that you can better understand. In first case, the result is rational. In second case, the result is irrational. So what we can conclude is when two irrational numbers are added, the result may be either rational or irrational. We cannot just predict that the result is always rational or always irrational. So here comes for subtraction, then for multiplication, and then for the division. So I hope I have made clear the concept that when we four mathematical operation, addition, subtraction, multiplication and division are applied in rational numbers, two rational numbers, between two rational numbers, the result is always rational, and in case of irrational number, the result may be rational or irrational number. So now look, see, when we add, subtract, multiply and divide rational number and irrational number, what is always result? Result is always irrational number. So three things you have to consider. See, when all the four mathematical operations are applied between rational and rational, so the result is always rational. When both are irrational, the result may be rational or may be irrational. Okay, and if one rational and one irrational is there, the result is always irrational number. See the example, 2 plus under root 3, this is addition, so this is rational number, this is irrational, again what it gives? Irrational. Similarly for subtraction, then multiplication, and then for division. I hope you have understood the concept that rational and rational gives rational number, then irrational and irrational number gives you either rational or irrational, then rational and irrational Combination of rational and irrational gives you always irrational number. Okay. Next, for positive real numbers A and B, the following identities hold. See, these are the identities you have to learn. I have here given one example also to understand this. C under root A plus under root B square. So this is the example, go through it. Under root 3 plus under root 7 square. A is 3 here, B is 7 here. So 2 under root AB, and this is plus B. So the result is 10 plus 2 under root 21. Similarly, for this, a plus under root b, a minus under root b is equals to a square minus b. See, this is similar identity you have already studied in your 8th standard, a square minus b square. Here b square is, since b is under root b, so b square will be b, because under root b multiplied by under root b gives you b. So here is the example. Okay. Next, rationalization. What is the concept of rationalization? Have a look over the definition. When the denominator of an expression contains a term with the square root or a number under a radical sign. What is radical sign? This one, under root. This under root sign is called radical sign. The process of converting it to an equivalent expression whose denominator is a rational number is called rationalizing the denominator. See what happens, students? In rationalization, we are given with an expression that contains either a square root or you may say a number under a radical sign. Radical sign means this type of sign, under root sign. So what is you, a fraction will be given to us and the denominator is in like this, in this form, and what we have to do is we have to convert it into its equivalent expression whose denominator is rational. Earlier it was irrational and we have to convert it into rational. So this process is called rationalizing the denominator. We will understand better with the help of an example. See how we are going to do with the help of an example. See, rationalize the denominator of 1 upon 2 plus under root 3. See, this is a rational number. Okay, so this is radical sign and we have to rationalize it. That means we have to convert it into an equivalent fraction whose denominator should be rational. So in these type of questions, what we generally do is we multiply numerator as well as the denominator with the conjugate of this expression. Conjugate means the term will be same with a different sign. See how we are going to do this one. 1 upon 2 plus under root 3, we will multiply with its conjugate. Conjugate means, see, the number is same, only the sign is different. See here plus is there, so the sign will be minus here. If minus is there, the sign will be plus here. Okay, that is called conjugate. That means we have to multiply the numerator as well as the denominator with the conjugate of the given number. Okay, so while solving it, what you get? 2 minus under root 3, and here this is the identity a plus under root b, a minus under root b gives you a square minus b. So a square 4 minus b is 3, 4 minus 3 1. So we get the result 2 minus under root 3. Okay, so to rationalize the denominator of 1 upon under root a plus b, we multiply this by under root a minus b upon under root a minus b, where a and b are integers. So what we have to do is, to rationalize the denominator, we have to just multiply the numerator and denominator by the conjugate of the given number, and where a and b are integers. Okay, so let's try to solve a question. Rationalize the denominator of 5 upon under root 3 minus under root 5. Yes, hurry up, students. Try to solve this question. What you have to do is just multiply numerator and denominator with the conjugate of this number. So what is the result? We will get an equivalent fraction and whose denominator should not be in this manner. The denominator will be a rational number. I hope you have done. So let's look for the solution. See, here minus sign is there, so we will multiply it with the conjugate, that is plus sign. Okay, so this is again identity we have used here. So 3 minus 5 minus 2, so here comes minus 5 upon 2 under root 3 plus under 5. What is the denominator here? 2, which is a rational number. So I hope you got the concept how to rationalize the denominator of 1 upon under root a plus b. What simple step you have to do is multiply the numerator as well as the denominator with the conjugate of the given number. Okay, next, laws of exponents. See, exponents will be given to us. What is exponent? I think I need not to explain you. Okay, the powers. Okay, you may say powers are given to us, and how we have to solve the questions. Just have a look. See, under root a is always written as a. What is under root means? Power is half. Okay, so here I have given one example. Under root 4 may be written as like this. Next is cube root of a. That means the power of a is 1 by 3. So here again one example is given to us. Next is n root under root a. Okay, so power is nth root, so the power will be a 1 upon n. So here is the example. Now see, very important. See, here two numbers are given, a raised to the power p multiplied by a raised to the power q. Dot here represent multiplication. See, base is same in both the cases and powers are different. So we have already learned that when bases are same and the expressions are in multiplication, the power gets added. Okay, so a p plus q. See the example, 2 raised to the power 5 dot 2 raised to the power 3, what it becomes? 2 raised to the power 8. Next is when bases are same, okay, powers are different, the expression are same, but the mathematical operation is different. Earlier here multiplication was there and here division is there. When multiplication is there, we have to add the powers, and when division is there, what we have to do? We have to subtract the power. Okay, p minus q. There is a basic, this is the basic difference between both. Don't get confused. See, when multiplication is there, we have to add. When division is there, we have to subtract. Okay, because we know that multiply adds up. So you may refer to this, that multiply, when we multiply something, the number increases. So increase means addition will be there. And when we divide something, the number decreases. So p minus q. So here subtraction will be there. This is just a type of hint to remember the things. See the same example, same units we have taken. Here division is there, 5 minus 3, 2 raised to the power 2. Next is a raised to the power 0 is equals to students. Many students get confused regarding this. What they generally do is a raised to the power 0 is equals to a. No. Something raised to the power 0 means the complete value is equals to 1. See, 2 raised to the power 0 is equals to 1. 5 raised to the power 0, 1. 7 raised to the power 0, 1. Every time whatever the number here doesn't matter at all. If its power is 0, that means its complete value is 1. Next, if the power is exponent is in negative form, so we will take the reciprocal. Next, see, when multiplication is there, when bracket is there and two powers are there, we generally multiply both. Now a raised to the power p dot a raised to the b raised to the power p. See, this one and this one seems similar, but it is not. See, here base was same, powers were different, and in this case powers are same but base is different. So what we have to do? We have to multiply both the bases a into b and take the power common like this. So this is the example, 2 raised to the power 5 dot 3 raised to the power 5 is equal to 2 into 3, that is equals to 6 raised to the power 5. So I hope students you have understand how to use laws of exponents and what are the operations on real numbers. If still there is any queries, please let me know. I will try my best to make it clear. Thank you students. Have a nice day.